Let's continue where we left, and let's try to improve the way we let Animancer switch or change states when we use ORK Framework abilities. So for that purpose, I already imported a script that I wrote, Animancer nodes. I don't want to make this video longer and you watching me make mistakes and typos as always, so let's just dig into the script and let's see what we have here. So to make our custom Machinome schematics nodes, we need to inherit from the base schematic node and also have the namespace Game is Love ORK Framework schematic nodes. So it will know that by reflection it will show this node in the ORK Framework editor. Of course, we here in the node info we set the path we want this node to be shown. We are going to look at it in a bit. And the first property that I have here is the state name. So this is the Animancer state, and we are using the editor reflection field type, so it will by reflection look into all the classes in our project and search and show us all the classes that has a character state type. So as you may guess, this is not a generic solution for all the Animancer state machines. This is a dedicated solution for this project because this type, character state, is a custom type that we have in this project. So for example, if you in your own project you have, instead of character state, actor state or player state from Animancer plugin, then you need to change this type here if you want to reuse this node, of course. The next property is the schematic object selection. I call it character. So this will allow us to determine whether or who is triggering this node. So basically the combatant having the machine component on it, and this is something that we can select in the node as well. Next, I added the time between values. So this is just to have an option to wait a little bit if we may have several characters or we want to change the state in several characters. I don't plan to use that scenario here, but I just added this as an option. And of course also I added a debug log function. That is something I miss a lot with Machinome and ORK Framework schematics, because although I know that we can debug the schematics by keeping the editor open and add breakpoints, I just want sometimes just to get a quick feedback in the debug log of what's going on in the schematic itself. So I added this feature here. When we execute, this is a mandatory override that we need to add to the node. So when we execute, we'll fetch all the objects, game objects, in the selection object selection schematic. And from this list, we then call our own custom runtime class that we have below, where we can let's go there. This is the runtime class. So we pass the list in the constructor. We pass the list of game objects, and then we loop through all these game objects, and we search for the actual state or the Animancer state or the character state we want to try to enter. And for that I added also a new class, character state helper. So this is something I borrow from the Machinome. So let's do an F12 to go there. So this is a helper class, and from here I'm using the Maki reflection handler in order to get the type or interface and successfully return the proper character state. Because if I show you here in the Animancer node, we are setting just the name of the state, but with only the name we cannot retrieve an actual mono behavior. So that's the reason we are using this character state helper in order to retrieve the actual class or mono behavior that is attached to the game component, to the game object. Okay, so if we were now to go to the GameIsLove editor or Machinome editor, and if we remember, if we go to the status abilities, we have the backstep ability, and in the battle animation we have this dodge ability schematic. Let's double click it to open it, and what we were doing here is change this variable, this object variable that we have added to our player. So what we can do now is right click and search add node. We have Animancer character TrySetState. So here we can type the state we want to try to set, and it needs to match the name of the class we have already created before. So we go to gameplay, behaviors, characters, states. So we have this DodgeState. So let's start typing Dodge, and we can see now that from reflection Machinome is already suggesting the class. So this is good. Is going to be this class is going to be found in the machine object. So this is the combatant running this machine ability, or the character. It could be the enemy in the future, so we can leave it as it is. But it's important to know that if you remember, the combatant component is added to the root of the game object, whether this state is located, if we search here the hierarchy, is located as a child of the player in the states game object. So let's add here child object is going to be a path, and the path of this where we can find this child is going, the name is going to be states. Then we have the option to either this option for time between or wait between. In this case we don't have any more nodes, so we can just remove or uncheck the wait between, or you can leave it. It will not impact. And this is our debug logs feature that we added to the node, and here we can determine if we want to log in the error category, log or warning. Let's select warning in this case. Of course we need now to remove this guy from here, and we can link the settings or the first node to our TrySetState, and don't forget to save the schematic. This same schematic, this DodgeState, this Dodge ability schematic is also used by the roll ability, as we can see here. So we don't have to change anything after all in this ability. So let's save once again. Let's close up the editor framework, and we need to make a little change here in the DodgeState. So let's open up that script. So let's double click on the DodgeState script. There we go. As we can see here in line 22, the condition to enter this DodgeState is to have this object variable set to true, this Dodge variable. So since now we are using the ability battle animation schematic to trigger this state. We no longer need this to be listening to this variable object. So we can just comment it, these lines, not down below where my cursor is here. There we go. And if you scroll down in the animation end event, we were checking or setting the object variable to false when we ended this animation, or whether the roll, the dash. So we no longer need to do this. So we can just comment this out for the time being, or we can just remove it, delete it. And when the animation ends, we try to set the default state. So the default state, if you remember, is the multi-state where we are playing the dodge state, the locomotion state, and the strafe state. So let's go quickly to Unity, and we have the player prefab here. We have the states, and if we see here in the inspector, this is our default state, this multi-state that is going to loop through all the state in this list and determine whether it needs to enter. So because now we are forcing or trying to enter the dodge state via the ability from ORK Framework, we no longer need this element here. So it is just safe to remove it. And then we can add our dodge state, and actually we have it already here, dodge state. So we don't need to do anything else, and we can think that at this point we can test it out. We're no longer listening to this variable, so let's save the changes. I see I forgot to save the changes. Let Unity compile and let's give it a try. Okay, so before hitting the play button, you may notice that I made a change in the instance that we have in the scene, not in the prefab. So that was my mistake. So let's select the object here and click on select. So now we can modify the prefab, and let's open the prefab actually, and here in the states you see still the dodge state is here. So let's just remove this from the list. Sorry for that, guys. Let's save the changes in the prefab, and now let's make a little bit of room. Let's check the console for the logs that we added and hit play. The dodge state will be triggered whether we roll or we backstep, or when we are in the dash state. So now we can see we backstep and we can see all the logs from our custom schematic node. Let's try to roll now. For rolling we need to be with movement. So we roll and we have now 2 entries. So this is working just fine. There we go. There is still a little bit of delay in the input, so I'm pressing the B in the gamepad, and you can see there is a call there to the TrySetState, but nothing changed. 7, 8, 9. So I think there is the issue here is how the input from the new input system is sent to the ORK framework in the input keys. So if we stop and we go into the Machinome editor once again. Just to remember, we have the base control and we have inputs keys, and we got this Xbox B for the roll, back, step and dash, as in the description states. And if we scroll down, we are reading using the actions, the input actions from the new input system. And we have timeout set to 0 and input handle down. So I believe it's something here that is causing this some sort of delay, because in the control map where we set to either, here where we use the input key to either roll or dash or do the back step. Well, we know that the list or all the control keys here will be executed in order, so it will try to, can I enter the sprint, or can I do the sprint? No. Can I do the roll? No or yes. Can I do the back step? So it will go from the top to the bottom, and maybe this is causing this delay, so we might need to move these control keys to their own control map. Perhaps that's something I will investigate later on. But at least at this moment, I'm happy that we are able to change the Animancer animation states via the Machinome schematics. So that's a good improvement in the system that we are building. And on the next video, I want to cover quickly, before we dig into adding more animations, about, for example, the footsteps or playing animation sounds when we move. So let's cover that on the next video.